Hello, and welcome to another episode of Hacking with Friends. My name is Kody Kinsey. I am a security researcher with Varonis, and this is my production gremlin, Michael.
Security researcher.
Yes, who is going to be working with us today to try out a really cool new attack that brings an existing attack that we've covered before down to an even, I would say, cheaper and easier level than it's ever been possible before. So what I'm talking about here is a really clever social engineering attack. And previously we demonstrated this using Airgedon. But Airgedon has a couple of things that are required before you can actually do this attack. And while it is very successful, and I think one of the best demonstrations of how you can hack someone's Wi-Fi password without really even doing much hacking, again, it does need some stuff. So you need a computer to run Linux. So that's already a requirement that at least is going to run you a Raspberry Pi. And you also need a Kali compatible wireless network adapter, which is able to be put into monitor mode. So right there, you're already running yourself, well, if you count getting an extra adapter for the Raspberry Pi, you're probably at like between $60 and $100 just with all the accessories there. So this attack, while possible, does require some extra hardware, and it requires you to be able to do all this stuff, at the minimum, be able to install a program and do all this other stuff in order to get it up and running. Thanks to efforts by my friend Stefan Kremser, we have now shrunk that down into this. So this little,
that's tiny.
Yeah, this little microcontroller that goes for, depending on where you get it, you can get it on Amazon for like 10 bucks or less. Yeah. On AliExpress, you can get it for like $3. But this ESP8266 is now capable of some of the same attacks that we've used against Wi-Fi that were much more advanced. And the reason for this is, well, some of it is secret, based on some advances with the ESP8266 and what we were able to do with it. But really the point here is that we are able to do a couple extra things that weren't really possible before that are security related on this device that allow us to test Wi-Fi security in new ways. So let's say that you picked a pretty strong password. Well, the Airgedon attack that we're emulating today with this tiny microcontroller works like this. Rather than acting like a traditional Wi-Fi attack where I try to brute force the password by grabbing a handshake as soon as a new device tries to join, this is entirely different. We're not really trying to brute force the password here. Instead, we're trying to get a, let's say, a gullible individual to just give us the password by creating a context that seems plausible. So in this case, let's say that you're at work, suddenly your Wi-Fi cuts out, and you look at your list of Wi-Fi networks and you see that there's a Wi-Fi network with the exact same name as yours, but it's open, it doesn't have a password, and it's just sitting there, and you cannot connect to your normal Wi-Fi network. It seems like something's really wrong. So if you were to connect to this open network, a phishing page pops up that says, hey, I'm your router and I'm restarting, and I need you to enter your password in order to enable this critical update. Now for the average person who just lost their connection and isn't really sure how their router works anyway, most of their inclination would be to just put in their password and get on with their day. But there's an extra surprise here for people that are a little skeptical and maybe put in a fake password, hoping that that will make this attacker go away. The way that this works is it actually checks the fake password that you put in. And if you put in a password that's not the right one, it'll try it against the real one and see that it doesn't work to log into the network.
That's really clever.
Yeah, so it basically convinces people that it already knows their password by just checking the fake password that they're putting in. So if you just type in like blah, 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 and think that this is going to be like, all right, thank you for your password, like a dumb phishing page, then you're going to get a surprise here because while it doesn't know your password, it's going to behave like it does. Yeah. And this is really the insidious part of this attack because it can ensnare technical people as well as especially non-technical people.
I was going to say, that's like one of my go-to tactics. Anytime I think a page is a little fishy or something, then I'll just like type in a wrong password intentionally and see what it does.
Yes. That's a good tactic. If you get hit with the phishing page and it allows you to log in with the wrong password,
yeah, then you immediately know something's wrong.
Yeah, sketchy. So this is one of those examples where you can get phished with Wi-Fi. It's pretty funny. And right now this is geared much more towards phishing mobile devices. So I can share a screenshot of what this looks like popping up on my phone. We're not going to try to broadcast from my phone today. Sometimes the auto direct works and sometimes it doesn't. On a Mac OS versus a Linux computer, we'll see today, it virtually always works on a Windows computer, but we're not going to test it with that today. So this is a really new attack. This is something that has just been implemented in the new version 3 of the ESP8266 Wi-Fi Deauther. So we taught this in the class that we did, I think like a week ago. It's all very, very new stuff. And I'm really excited to share with you guys today some of the new stuff that we've been able to do. Stefan would be on this live stream with us, but unfortunately it is solidly the middle of the night in Germany. So while I would love to have him on, I think that at 4 in the morning, he probably wouldn't have very much to say.
Might be a little sleepy.
Yeah. So, all right. So let's go into what's going to happen with this attack. We're going to need to install a way of interfacing with this device, which is called the Huhnitor, which in German means like the chicken monitor. But basically, it's a serial monitor that works cross-platform and is specifically designed to work with the Deauthor on the ESP8266. So first thing you'll need is one of these microcontrollers. The second thing you'll need is something to connect to it, so a data cable for micro USB.
One of these.
So if you have a power only cable for micro USB, then it will not work. You need to be able to exchange data with it.
Yeah, that's
so if you
always
have
a
some
gotcha.
like super just awful cable like laying around that's like dirty and maybe a little damage, you plug it in and it powers up, but it's not working. Try another USB cable. That's our #1 recommendation. So once you get one of these really easy to find devices, I recommend buying a D1 Mini. You can get them on Amazon or anywhere else. You can also get a Node MCU, but there's different versions, and I'm not going to get into which ones are good and bad today. All of them work, but some of them are just very ugly and take up a lot of unnecessary space. That's the V3 Node MCUs, I think. But again, I highly recommend.
Let
the
us
D1
know
Mini.
in the comments if you want us to do a microcontroller roundup.
Yeah, we could. There's a lot of cool hacking that can be done with these microcontrollers. So if you guys want a roundup of that, we could show off some cool toys. All right, so with this, we have our cable, we have the Huhnitor, and I'm going to show you guys how easy it is to do that. So let's go ahead and switch to my screen, and we'll go over a couple things right off the bat. So I'm going to plug this in. And I think on Mac OS now I get this lovely warning. The first time I did this, that warned me that the driver that I'm using for this chip is no longer going to be supported in updated versions.
That sounds like a problem.
Yeah, but I mean, I'm sure it'll all be updated. It'll always break stuff with Mac OS. So here's our phishing page. This is not the most sophisticated phishing page, and it doesn't really even stand up to the kind of weak phishing page that Airgedon has up.
Yeah.
But we are just showing you a proof of concept. Obviously, we could improve this phishing page. Really, we want to prove that we're able to extract a password from someone by basically forcing them off a Wi-Fi network, creating a new network for them to connect to, and basically being able to get the router password from there.
And so with the Huhnitor and the V3 Deauthor, would you be able to go in there and put your own custom HTML page?
Right now, you would need to go into the code and change it yourself. It's certainly possible. You need to get into Arduino IDE and be at least a little bit familiar with coding in Arduino and C++, but there's absolutely no reason why someone who was familiar with both those things couldn't go in and start making their own pages. It is our goal to update this and make it a better actual live attack tool for pen testing and people who are auditing security. Being able to load your own page is a really great feature, but it takes a lot of work. So we're currently talking about some really exciting things, such as moving this platform onto the ESP32, which would give us a tremendous amount more power and the ability to use a micro SD card interface and some other stuff that would allow us to do that more easily. And then we could talk about something where you just plug in a new micro SD card. You don't have to reprogram it. But right now, in order to change the page, you would need to basically compile a new bin file, upload it via Arduino IDE. It's all kind of behind the scenes in Arduino. You would just change the code, press upload. But that's what has to happen.
I think it would be really cool too if you could have multiple different pages. And so, for example, if you were attacking a network with a Cisco router, you could pop up a page that's branded as Cisco, and it looks all professional.
Very doable. So what we can do with the new version of the Huhnitors, with the new version of the Deauthors, we can actually detect what manufacturer every device was made by. So that allows us to offer, for example, custom phishing pages if we wanted to in the future, based on the manufacturer of the router.
Yeah.
So if we had a micro SD card that we could plug into a little slot on a ESP32 in a future version of this, we'd be able to load up a whole bunch of different phishing pages, select the one that was appropriate and a match for the router that we were basically phishing, and then we would attack the individual users that were connected to that Wi-Fi network by kicking them off one by one and presenting them with this fake update that they have to sign off on in order to get their internet back. Very annoying, but most people aren't really knowledgeable enough about this sort of thing at a small business or a small organization, or if you're going after individuals or people working from home, to really make a difference when it comes to being wait a minute, this is sketchy.
Yeah, exactly.
So we haven't fully implemented the password checking on the microcontroller, but it is pretty easy for us to do using built-in functions with the ESP8266. So all of this that we're showing you today is capable of being pushed even further and being even more viable as a real tool. This is a proof of concept we just want to show you as an example of how cheap it is to be able to herd someone onto a new Wi-Fi network, or just be able to present them with a phishing page.
Yeah, I think this would be really powerful too as like sort of a throwable Wi-Fi hacking device. And what I mean by that is like the kind of device that you could like abandon in a threat area. So like if you're a pen tester and you were doing some physical pen testing, and you could just like drop this in like a plant in the lobby or something, and then have it powered with like a LiPo battery and come back to it.
I hate that idea, but I have a better idea. And no one else likes it, but I don't care. My final idea for this is to put it in the frame of a light bulb, a smart light bulb that has an ESP8266. It has its own power supply, and basically you can start it out as it mimics a plant. You start it out as a seed. It basically probes around the area until it's able to trick one of the users of a nearby Wi-Fi network into submitting the password. As soon as it gets access to the internet, it upgrades itself with new firmware and becomes a more robust attack device, and is able to be controlled remotely from a command and control server. So you basically have an implant that is blindly groping around for a data connection using these tools, and then when it finally is able to get access to data, it becomes a more dangerous version of the first stage.
Yeah, that's a very interesting note too on that is if the ESP is such a common device in IoT products, and there's no physical hardware changes for this, it's just flashing new firmware, could you potentially compromise like
Devices
the
already in place?
ubiquitous like smart light bulbs?
Yes. So there is a way to flash firmware over to existing smart light bulbs. So in theory, we could take this terrible device I just envisioned and flash that over to existing smart light bulbs, and they would continue to function more or less like normal smart light bulbs, but they would also be evil, and they would start doing things like phishing users, trying to get a password, or trying to get access to other Wi-Fi networks, so it could download a payload and then start attacking really whatever we want. So if you guys want to see how this can be taken to the extreme with routers, you guys should check out what the CIA did with their Tomato. I believe it was like So it was Cherry Tree and Cherry Blossom were the two things where they took the Tomato open source router and turned it into a weapon, and then infected adversaries' routers with this basically command and control like architecture that allowed it to connect back and turned their router into a piece of spyware that would do things not unlike what we're talking about here. So this is of course a much scaled down version of all of that. We're just talking about proof of concepts of individual pieces, but making an IoT device like a router evil and then using it to spy on and attack your adversaries is absolutely nothing new. So there's lots of really interesting things you can find out about how this has been done by nation states. If you want to Google cherry blossom and cherry tree, you're welcome for being on a list now for like repeating those on a live stream repeatedly. But it's a really interesting way of understanding how these can be weaponized and what we're kind of touching when we're using this stuff. Yeah. So not a very impressive phishing page, I know, but this is how easy it is to get started with this. So if we were going to do this via Airgedon, we would need to run a Linux computer, and we're going to take a look at this on Michael's computer in just a bit to see what the difference is between just running this on a macOS computer and running it on a Linux computer. So first off, you cannot run Airgedon, as far as I know, on a macOS computer. I don't know if you can run it on a Windows computer either. It's pretty much Linux only. So right off the bat, this attack that we've adapted is more robust in terms of what operating system. It's more cross-platform, and you can get started with it really quickly. So if I want to run this, I can type brew install Huhnitor, and I have Homebrew installed. It is super easy to install. If you want to install it on Linux or on Mac OS, you can go ahead and just copy and paste this into your terminal, and it is as simple as that. So we are running Homebrew on this Kali Linux computer. It also is a package manager for Mac OS. It is always loaded up with the most recent version of the Huhnitor. So it is probably the best way to go ahead and get started with this. All right, so this is going to update Homebrew. It's going to tell me I already have the Huhnitor, and that's great. And also, one thing to note is the Huhnitor is written in Rust. So if you want to learn more about Rust, it is a very safe language to write in. It's very memory safe. It has like a lot of built-in things that programmers really like. So James, our friend who is helping us develop this, a contributor also known as Howdy Burgers, has been putting a lot of work into this interface to make it work really well across different platforms. So it really is the interface here that makes the difference. And of course, Homebrew is going to take a minute updating since I'm watching it, but I'm going to split my terminal and I'm going to just start it to show you guys what it looks like. You just keep thinking about that. So we immediately get a
Space
space chicken. That's how you know you've done the right thing. And then it's like, all right, go ahead and plug in your thing. So it's already detected it actually. So it gives you a list of available serial ports. But if you don't want to mess with that, if you just want it to automatically be, I need to see more of this chicken.
Yeah, that's a glorious chicken there.
Yeah. Homebrew, just do what you're gonna do in silence. In fact, I'm gonna close this. You guys can. It's just brew install Huhnitor.
Yeah.
You guys can imagine what that looks like. I just don't.
And it installs pretty quick normally too.
Yeah. Well, you just get out of here. But I want to see more of this chicken. I'm gonna close this.
And you like permanently damage your Mac because
Beautiful.
you closed it during
All
your
right. So
install.
I unplug the microcontroller. I plug it back in, and if James has done his job right, there we go. All right. So I get this beautiful waterfall of garbage, which is unique to me. No one else has really seemed to get it. But outside of that, we then get our disclaimer, and then we're in the tool. So I can type help. And these tools are being run on the microcontroller. And they're all colored and fancy and nice because that's the way that they've made this. And I really like that.
That's a lot of tools.
Yeah. So these are all the things that you can do. You can do scans. You can do authentication scans. So you can see if anything is trying to authenticate to a particular network. You can get your results. You can send beacons frames. You can send Deauth frames. You can send probe frames. You can even target when you're sending Deauth frames. You can decide whether you want to send disassociation or deauthentication frames. They're different.
What is the difference?
So both frames are used to disconnect a device from a network. Disassociation frames are more used if the station is powering down or if you're going out of range. It's like, okay, you're going away now, goodbye, and it kicks you off the network. Deauthentication frames are usually more used for things like the password has been changed and you have the wrong password, so you must go off the network. Or you're connecting to another network and you're terminating your connection with the existing network.
Is there a reason you might use one over the other?
Effect. Different operating systems will react differently to different packets. And like I found that some devices will be kicked off with disassociation frames very effectively, even more so than deauthentication. Other devices react better to a combination of the two, and some just don't react to one of the two. It really depends on your target. Deauthentication frames are usually the way to go. They're stronger in terms of effect, but disassociation frames also perfectly valid. And it's cool to disassociate.
I was thinking like...
Good job dealing with that comment. All right, so then we also have... probe frames that we can send, which will cause certain types of like the Wi-Fi pineapple will like freak out if we do this and start creating a bunch of like fake networks, and we'll be able to spot it. We can create aliases for devices. So if we have a device we're tracking or we want to keep track of, we can alias it to keep track of it. And of course the chicken command. And then the AP command is really what makes this all possible. This gives us the ability to create an access point that's an evil access point that redirects anybody that tries to connect to it to a phishing page. And that's really what we're trying to do today. So we can do things at the same time as well. This allows for scripting. Right. So we can create a script that when run will automatically do all this. Or we can also create scripts. We can basically run multiple commands at the same time just by separating them with, I think it's 2 semicolons. And that allows us to do like kick somebody off of this network and create this access point at the same time.
Okay, so you could make it potentially where it automatically detects a new network. When it detects a new network, it creates a duplicate of that and then deauths people on the original network?
Yes. That's right.
That would be really powerful.
However, the duplicate that it makes has to be one with no password, because we don't know what their password is, and we can't be creating a network that doesn't have the same password because they couldn't connect to it.
But that seems like really useful. Like you just make a physical button on it, and then have that script run anytime you press that button, and just that would be insanely powerful for pen testers, for anyone like that.
Yeah. So we're gonna type scan. And it's going to do its automatic scan, which is, again, it can be customized because right now we're scanning on channels that don't matter and don't actually exist in the United States. So there's no real reason to do that, but I mean, hey, whatever. So it's going to scan for about 20 seconds. It'll bring back the results, and this will represent what we can actually do on this network. So you can see a list of targets. Right now, there weren't a tremendous amount of targets found. So if we wanted to increase this, we can probably shorten the scan and stuff. But basically, we have one target that we found. It's an Intel device. I believe it's probably the ThinkPad. So then what I can do is I can select this and I can kick it off the network. I can, let's see. So if I want to do a compound command, which is, all right, a couple things. First, if I want to see all of the instructions, I can type help. dash S and see a short version of the help command instead of that big long one.
Mm-hmm.
So in this case, I want to do two things. I want to attack this, and then I want to create an access point at the same time, just to show how quickly and easily we can do this. So I can type Deauth, and then I have to refer to this by its position in our station list. So Deauth, and then station-st, and this is station number 0.
Yeah, okay.
And then...
And does it matter what order you do this stuff in, or can you just change?
I don't think it matters the order,
Okay.
but you can put in delays now. So now you can put a delay between one and the other. So I can also do APS, which is the name. It's going to be...
Wait, what's the semicolon for?
FakeNet. Hold on. And then no password. All right. So first we have Deauth station number 0. So it's going to kick your Kali Linux computer off of the network, hopefully. And then we're creating the access point called FakeNet. So if we look at the AP, is the AP included in here? Yeah, AP. The S is for the SSID. That's the name. We have no password. And then...
Oh, you can even make it like a hidden network.
Yeah, we could. So let's go ahead and see if this works. So we're running two commands at the same time. We're running a deauthentication attack. And look at that. Your computer suddenly can't seem to connect to Wi-Fi. I saw it fluctuating.
Yeah.
So I'm assuming that you are the one that we're kicking off. Otherwise, that would be very rude. But in general, what we'll see is you should be kicked off the network and then go ahead and connect to the FakeNet. And we'll take a look at what this looks like on my end.
Okay, I believe I'm connecting to...
All right, so
FakeNet.
Michael's now connecting to FakeNet. And once you're fully connected, go ahead and open a browser window.
And just random page?
Yeah. In fact, you might just close your browser and then just open it again.
Yeah.
So what we're looking for is here on my screen, we're looking for something called connections. So as soon as we have a device that's validly connected to this network, usually on a lot of different operating systems, it'll offer the ability to sign in. And you'll typically see this at like a coffee shop or something that like allows you to join but requires you to consent to some terms of service or something. So if not, you can for now just, are you connected?
It seems to be.
It's okay.
I can.
So for now, just go to 192.168.4.1. And this is what normal users, especially on Windows and on mobile devices, will be redirected to.
Do you want me to show that?
No, because it didn't work, did it?
Yeah.
So
4.1? I don't think it's connecting. It's well, it's giving me the whirly wheel of death. It shows like FakeNet, and then it gives me an option to disconnect.
All right. Well, if you're having a hard time with that, I can connect this way.
Yeah.
So here, as soon as I connect on my phone, once I see the network actually, come on, scan the network. We should see a couple things. One, when this is actually, where is it? When we actually connect to this, we should see, oh my God, I'm so upset. Why is this not, I'm just gonna turn this off, turn it back on. Now scan and show me this.
Maybe it's because...
No, here it is. Okay. So my phone kind of automatically figures out that it needs to go to a page in order to like successfully connect to this network.
Yeah,
so,
like a sign-in page.
Yeah. So I'm obtaining the IP address. And again, this could be also failing because we're running two commands at the same time. I haven't...
Yeah, I think it's not assigning an IP address to our devices. That's why we're not being able to connect.
Possibly. So there's ways around this. We can... First,
maybe if you try it without the compound command.
Yeah, so I'm going to try it without the compound command. So I'm just going to run the APS FakeNet. Okay. I'm joining on my phone. There. Okay. So we see that as soon as my phone joined, it generated this. And if I tap on the tap to sign, see it says tap to sign into network. I'll tap. I can see that it generated a fav icon, and then we can see that this this particular device, 192.168.4.2, is now connected to the network. All right, so now Michael has it as well.
Yeah.
So if I type in the password on my phone,
I think let me
I can press submit, and look at that. My password is exposed. Yeah. Yeah.
What?
I know, it's ridiculous.
Wow.
How could it do this to me? All right, so let's take a look at what this command looks like running it a different way. So let's go the Airgedon route and see what the analogy to this is. Let's go ahead and go over to Michael's screen. Cool. And we've loaded up Airgedon here.
Yeah.
And right now we have one interface selected. It's the internal interface on this computer.
So that's WLAN 0.
Right. So we are going to go through our evil twin attacks menu. So that's option number 7. So go ahead and press 7.
Yep.
And again, we're using Airgedon here. If you haven't heard of it, it's a really great, they call it like a Swiss Army knife of like attacking. I keep using that. No, it's like it's a complete attack framework for wireless pen testing. Is how I would describe this. So we're going to do an evil twin attack with Captive Portal. Yes, but first go ahead and put your card into monitor mode. So go ahead and that's option number 2.
2. Cool.
Okay, so already we need a wireless card, and we have to put it into monitor mode. Press enter. We're going to select option number 9.
And so it's important to note that that's changed a WLAN 0 model.
Oh, I don't know if it requires this, but it's really annoying if it does and we don't select it now. Select, go ahead and do number 4. And we're going to explore for targets. It may discard these, but, you know, whatever.
Oh, I'm getting a bunch of stuff now.
Great, great, great. So I'm also connecting to the Wi-Fi. So go ahead and press Control-C.
Control-C.
Great. So it gives us a list.
Oh,
and,
that's pretty.
And you can see that there's an asterisk for all the different networks that have traffic on it. So these are networks we can easily attack. So we can also see that this is capable of attacking 5 gigahertz network, which is something that admittedly this sweet little microcontroller cannot yet do.
It's also,
nor will it ever be able to do because it does not support 5 gigahertz Wi-Fi at all.
Interesting to note that it sees both access points in the house because we have 2 access points on our network. Yeah. So that's why you see the same network name twice.
Yeah. Well, it's not the same. One of them is 5 gigahertz, and there's two.
No. There's 2 of the 2G and 2 of the 5G because there's silly. 2 separate access points.
Yeah, extended service sets. Yeah. Okay, so right now we have the ability to distinguish between these two. I'm connected to the 2G network, so go ahead and select option 7. We're going to target the 2G network, and then we have some options. So we're back to this menu. We'll select option number 9, which is an evil twin AP with Captive Portal.
Okay, and that's just basically what we...
Oh my god, so annoying. So yes, it's going to press enter again. It's going to like search for networks again, even though we just did this. Some attacks on Airgedon require us to do this in advance and then give you very few options to go back if you don't do them. So just out of an abundance of caution.
Do you want...
Control-C?
Yeah.
We'll select 4.
4. Hopefully it's that way.
All right, so then we're going to pick the way that we're going to attack. So we're going to do a disassociation MDK4 attack. Actually, let's do AirPlay NG. It works really solidly. So do option number 2. Press N for that. That's DOS pursuit mode. That's if the router starts broadcasting on a different channel, it'll scan and look for it.
Gotcha.
But we don't need to do that.
Okay.
All right, so do we want to spoof our MAC address during this attack? Type N for no. We could, but we're not going to. Do you already have a captured handshake file? No, we do not. So in this case, we're going to grab a captured handshake in order to compare it to whatever password they supply us. So this gives us, the hacker, the ability to know the password ahead of time. Go ahead and press Y for yes.
Oh,
you have failed everything. We can no longer proceed, and we now have to go back to the start.
I already had loaded up.
This is the reason why...
I thought we didn't have a handshake, though.
We don't have a handshake. Oh, wait.
Do you already have a handshake captured? I said no.
Oh, wait. Okay. Wait. Okay. In that case, type 60. Oh, okay, you didn't ruin everything yet. So I will also generate one manually just to make sure that it happens.
And so we're waiting for a handshake to pop. Oh, we got it.
Oh, wow. What a weird coincidence.
Yeah. Okay, so Control-C.
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 Oh, okay, yeah.
Wait. Be patient. Oh,
it's waiting.
It's still going to...
It's going to wait.
Okay, congratulations.
All right, so we got the handshake. So go ahead and press enter to save it. Do you see how like this attack is getting like a little complicated?
Yeah.
Like looking at it both ways, you know.
Enter to continue.
Press enter to continue. Oh my god. Okay, so type the path you want to save the friggin' password to. Just press enter. It's fine. The path is ready and you write permission. Press enter again.
There's a lot of entering.
Okay, this is where Airgedon is undeniably better than this proof of concept on the ESP. So here we have the ability to do this whole attack in some other language. Which one should we do?
Catalan?
No. Let's do
Deutsch.
Let's do German out of respect for Stefan. So do number 10. We're phishing in German. Press enter to continue. And then, oh my god, like we finally have this big thing.
Okay, I think we're doing things now.
Yep. All right, so I'm gonna. Wow. Yes. So so much stuff.
Sorry, this is so tiny. I can't really.
No, it's
because there's like a million screens that pop
all
up.
sorts of stuff is going on. Like this Python or this Linux program is working really hard to create an access point, kick everybody off the network. I can no longer join the network. I'm kicked off. So let's go back over to my screen and see what the situation is. So I'm gonna stop this command. So just on my MacBook, I have switched over to the 5G network because I can no longer connect to the 2 gigahertz network. It just does not work.
So in some ways, I mean, it's very little protection, but 5G is somewhat safer.
Not on this, because you could have just selected the 5G network and then we would just be doing this there.
Yeah, that is true.
All right, so I can't seem to connect to the 2 gigahertz network. Isn't that a weird and unfortunate thing? So really my only choice is to
this other network.
Yeah, see if this other network pops up. So I don't see
Oh, yeah,
no, wait, I see it on my phone, but I don't see it here yet. So I still have to wait for this unfortunate. And yeah.
Can you manually make it scan again?
Oh yeah, well I can turn it off and turn it on. Turn off, turn on. But it'll just sporadically try to connect to the 2.4 gigahertz network. It's never going to work though. It's never going to give me full data. Turn Wi-Fi on, I said. Oh, that's not good.
That seems problematic.
Oh yeah. Well, okay. Again, this is not a problem with the tool. This is a problem with how the MacBook Pro does scans.
Yeah.
And like how infrequently.
Do you want to just do it on your cell phone?
No. I want to try to show it off. That's kind of the whole point. So right now my device can't connect to anything, and I'm a little curious as to why we can't see it, because we should be able to see another 2 gigahertz network right here, and it should be strong, and I can see it on my phone. So here I can see on my phone there's a Spectrum. I can connect to it. It's connected but has no internet. Weird. So then it asks me if I want to tap to sign into network.
Yeah.
And boom, I have a very similar phishing page. And on Michael's screen, you can actually probably see that there is some sneakiness going on. So it's detected that something is connected. It knows that something is up. And if I type in a wrong password now.
Yeah, so down here we can see deauths as they're going out. Here we see the IP address assigned to a device. Oh, there we go. We got one attempt. And it seems that the last password guess was my bunk password.
Which it turns out is not my real password. So this is going to keep on going until it gets the real password. And because we run this against our real network, I'm not going to put in the real password.
Yeah,
But really here, what we've managed to do is we found out that we can create this phishing page, which, by the way, looks pretty. It's not the least convincing phishing page in the world. My favorite thing is that Stefan chose to keep the same colors, so it is just green, and the only difference it says is it says please enter password to enable Wi-Fi network, and that's it.
Legit.
So there's not really any differences here between the phishing pages popping up. The fact that it's in German just means that there's a very, very short piece of text, and that when you put in the wrong password, it says, sorry, this is not the right password. Please, reconnect. So 2 different ways of accomplishing the same thing.
This is like tedious, and that seems like a one command thing.
Yes, absolutely. Yeah, so on what? Okay, so what I'm going to do is
how do I stop the attack?
Oh.
Just Control C.
Oh, yeah, it's just going to keep on going forever until someone puts in a vulnerable password. So yeah, one thing to note about this is it is a relentless attack. Airgedon will basically attack whatever devices you specify continuously until you decide to let them go. So in order for Michael to stop this attack until he gets his password, he can go ahead and press Control C, I believe, a bunch of times. Or you might even have to individually exit out of those windows.
Yeah, I think I'm gonna have to close each window individually. That's. I mean, if you do just really need to look super hackery really quick, that is a good way to do it.
Yeah, no, it opens a ton of windows and they all look really sketchy. So if that's what you're looking for, then it works pretty well.
Like if I want to get kicked out of a coffee shop instantly.
Yes.
Yeah.
All right, let's see. Okay, so now let's run through this one more time, and I just want to show everyone what this looks like on the ESP8266. So, all right, so in order to get to this page, we are going to set everything up and do it through the command line. So let's do Huhnitor. All right, we'll select option number 3 because that's the serial port it's connected to. We're connected. We're going to, let's just do scan and then CH1 to 12 because we don't need.
Oh, so CH being channel.
Yeah, so we can customize our scans. So we're only listing on channels where things are actually happening.
And that's because in the US, those are the only channels that are legally allowed.
Right. So if you were in Japan or like Europe or whatever, then there's going to be other channels that you can technically connect to, and those are like 13 and
14.
13, 14, yeah. So that is not an option for people in the United States. So yeah. All right, so we have a couple devices. We have one of them right here that's an Apple device, and it's connected to this network. Gee, I wonder if it's this exact device. In fact, it is. Wait, no, it's not, because I'm connected to the 5G. Whose Apple device is this?
It might be the production laptop.
Oh yeah, probably. It almost definitely is. All right, so let me connect on this, and then I might just run the same scan again. Scan ST. Oh wait, scan ST. That's for stations, and then CH1 to 12. So I've customized this even more. Now I'm not scanning for access points anymore. I'm now just scanning for stations, and I'm doing it on these numbers. Okay, so now I have multiple different Apple devices. I have 4 Apple devices, 2 of which are connected
The house
here.
has been infected.
Oh my God. What other Apple device do I have on here? Whatever. Okay, so one of these is probably my MacBook Pro. In fact, I can probably just find that pretty quickly. But either way, we're going to attack one of these MacBook Pros, and then we're going to pop up an access point.
That is an interesting point. Since this is an external device, you can attack the computer you're actually using.
Mm-hmm. Yeah, you can. So you can practice all this on your own device. So currently, I'm connected to my Spectrum. If I want to split my screen horizontally, I have config grep inet. I can see oh no, I actually just have to do ifconfig. I can see that okay, this is my MAC address. Wait, no, where is it? Oh my gosh, there's so much information and none of it is related to my MAC address.
Yeah.
Okay, well, whatever. I'm not going to dig through all this information right now, but I basically just, well, no, maybe I have to. Here it is. Okay, it starts with 8C and ends with DF. That's what I need to do. So starts with 8C, ends with DF.
2.
It's right here. So let's do help alias. So I'm going to alias.
Oh no, alias. What does that do exactly?
It's adding a name from my MacBook Pro, so I don't get it confused again. So alias mode add name MacBook Pro, and then it's station number. What was it?
2.
2. Let's see if this works. All right, so we so now we have an alias.
So you could just be like Deauth Pro.
Yeah. So I can just, so now this name is Pro, and I can just write Deauth Pro.
Mm-hmm.
Wait. Oh, wait, sorry. I have to index this as Deauth ST Pro, I believe. Wait.
A Mac.
Yeah, let's try that. Deauth. Whoa! All right. Well, Stefan will have to. Stefan will have to walk me through that again.
Yeah, yeah. It's doable.
Really though?
So what is the alias for? You said the alias is.
It's supposed to alias the.
The Mac, right?
Station to attack. I remember him saying that it just is an alias in the station list. So if I just wanted to do Deauth st2, I could do that too. Yeah, boom. It shouldn't require me to do that, and so I think I'll probably tell Stefan that needs to be made a little bit more clear, because intrinsically that's not like super user friendly to use.
Yeah.
But okay, so I'm attacking my own computer.
This is still alpha stages.
Yeah. So I'm attacking my own computer. I can verify that in Wireshark if I need to, but basically I will probably not find it possible to continue to connect to Wi-Fi. Of course, this is like the one time it probably will allow me to. Let's see. So I'm doing pings. I'm supposedly attacking this. Is it working now? Sometimes it'll also switch over and start connecting to 5 gigahertz and I won't notice. Wow.
Looks like it's on 2G.
Well, my worst nightmare is that I'm now attacking someone else on the network.
Good thing we secured permission from everyone that lives in the house before doing this live stream.
I'm curious if I wanted to just attack.
Which is something you should always do, especially, when you're trying things out like this for the first time.
So I just tried a slightly more aggressive command just to see if that kicked things up a notch. But I'm actually a little confused. This should really be like going after the network now.
Yeah.
It's a deauthor. That's what it does. It's in its name.
It literally has one job.
It
or at least it used to only have one job.
Interesting. All right, well, whatever. Submit a bug fix. I don't care. Stop.
Yeah, and if y'all do try this out, and you find any bugs, go to Stefan's GitHub, Space Huhn, and you can submit a bug report there. Because, like I was saying, this is still in alpha stages, so there's likely to be a bug or two.
Oh yeah, and I'm just like,
and some user error in there probably as well.
And I'm just like ramping up my attack like more substantially. Now I'm attacking like 3 separate ones and seeing if that does it. But
are you just saying like deauth everything?
No, well, so you're able to specify a range. So in this case, I'm just saying deauth stations 1, 2, and 3, and that should be these ones right here. They're all connected to this same network, and they're also all Apple devices. So that's very handy when it comes to targeting. And the ability to like see the vendor here is really what is helpful. Although I cannot understand why I'm not being kicked off the network.
Oh, do you have a VPN? No, that wouldn't
do
matter.
a damn thing. Yeah, absolutely doesn't matter. Yeah, so this seems to actually, now I'm curious. What is okay? So you can see this is not. It's not that this isn't attempting very aggressively to kick me off the network. I can see that these are packets that are.
Is your computer literally ignoring the off packets?
I don't know.
That would be really weird.
So these packets are being sent to what? Wait, F053?
That's not your Mac.
That's not me. Oh, right, because we're sending it to everyone at this point. We're sending it to any Mac. So there are other destination addresses that this is being sent to as well.
Yeah.
But
hopefully none of the Mac users in the house are doing anything important right now.
Yeah, well, it's just basically us. Yeah, that's interesting. So this is well, now I can't tell if I've been kicked off or not, but basically, like, this is the way that you would go about attacking and verifying that an attack works. Right now, I can see that I'm still able to get pings back. So apparently, this attack isn't affecting my MacBook Pro at the moment, although it normally does. So that is very interesting. But before I get too deep into that, how much time do we have?
We have about... we could wrap up now, or we have 15 minutes.
Okay. So let's do the AP attack. So AP S... my big faker, no password, and I don't think we need to do anything else, really. We could make it hidden, but that won't help anything.
Okay, so this is going to generate an access point called my big faker. Gotcha.
So then if I stop this meaningless pinging, stop Wireshark. So that should have stopped the attacks on the network. Great. I still have to trace down exactly why this didn't work, but we're going to then connect to our big faker if we can see it. I'm not very, oh, okay, we can.
Okay, yeah.
I'm not very enthusiastic about this MacBook's ability to connect to networks today.
Yeah.
All right, so it's connecting, it's thinking about it, it's gonna realize that it can't do anything. And this is where on a smartphone, on a Windows computer, and sometimes on a Mac OS computer, we haven't been able to get it to work all of the time. It will do a pop-up that says you have to sign into the network. I find I even sometimes have trouble, what am I in right now? Chrome. I even sometimes have trouble. I don't want that at all. I'll even have trouble like actually being able to like just connect to like a Starbucks network. But if I
Oh yeah, I've had problems with Macs before with like sign-in pages. Like sometimes they really don't like them.
Yeah, so right now it can't resolve anything. It doesn't know what to do. And if I try to open a new browser window,
have you tried navigating to the IP?
Yeah, well, I can. Of course I can. And that's going to be what I do if this doesn't work. But if I try to go somewhere, sometimes, I don't know, CNN.com.
You can also try like Google.com.
Yeah, well, Google, what is the difference? They're just websites you can resolve.
Yeah.
Yeah, so, and we're also literally on Google.com
already.
So it's not
I was
anything.
But like some devices that do similar things to this sometimes are weird about certain pages being able to redirect and others not.
Yeah, so this is not currently on Mac OS redirecting me, but on most other operating systems it would be.
I mean, I can always try on this.
Yeah, go ahead.
Let's see.
So when we are redirected, this is the page we get. And up here, back in our terminal, you can see that Mac OS isn't the same as a smartphone. A smartphone, when it connects to this, or Windows, when it connects to this, will automatically start generating. Oh, no, wait, never mind. So it looks like it did. So
I'm trying to connect to it right now.
Okay.
So.
Right. So I'm connected to this. I have an IP address. If I take a look at my IP address, I can tell that I have config grep inet. I can see that my IP address is 192.168.4.1, which is the one that I'm tracking here. So while Michael might be connected, oh, now I can see Michael. So Michael is at 192.168.4.3. So were you automatically directed to this or no?
No, I had to go to the IP address to get this.
Right. So on, like for example, on my smartphone, it will pop up and allow you to do this. On other operating systems, it will as well. Here, when you get to this page, it's basically the same as the Airgedon page, only we don't have instructions demanding that.
Yeah, but like that could easily be added as a text box under password.
Exactly.
Or
And
above password.
currently, this doesn't have the ability to validate passwords. So if I type in...
Oh, that's an interesting little thing. Yours says submit, but if I go, mine submit query.
Weird. That's very odd. Okay, so if I submit, then I can see that I get the result back, my fake password. So then it's not checking this. So this could be the wrong password. And the way it would do this is by just in real time attempting to connect back to the real network. And if it doesn't work, then just coming back with an error.
Okay.
But that's not fully implemented yet. The advantage here is we can deny someone access to the internet. We can target them specifically. And then once they're denied access to the internet, we can shepherd them over to this page. And we can basically make it so that this is the only option they have for restoring their internet. And people that don't understand the gravity of that decision will probably type their password into this text box. Although, again, I would probably spice this up with some instructions. It's not exactly easy to get someone to just type in their password to a box like this. Having some context, like, please type in your password to update the router. That might be a little more
I imagine there might be some hardware limitations, but if you could like put an image behind this that is like branded or do any minimum thing like that, I could imagine like 80% of people would fall for something like this. Just because like, Sally the housewife, right? She's gonna be like, I just want my internet to work, right? Like,
I'll remind you, sir, I fell for this. I fell for this.
I imagine too that like technical people could fall for it, like especially if they're like stressed or something like that.
Well, yeah, this hits at the worst time. Like, imagine your light bulb suddenly like spamming like a phishing page at you while disabling your ability to access Wi-Fi. That's gonna be really frustrating.
Or you got a work meeting to get to, Zoom call, something like that. Like,
yeah, so we are creating a phishing page on a very tiny device. And while there are some things to iron out, such as being automatically redirected, there is a lot of potential here. If one of these IoT devices found its way into a secure environment, it would be able to basically target and start attacking nearby people to try to get the Wi-Fi network password. So for hackers that are looking to basically push off the dirty work of having to hack Wi-Fi, attacks like this make it really easy to not only just go and do it manually, but even potentially automate it in the future, which I think is really exciting.
Especially for like $2. Like, I mean, okay, it's going to be a little more expensive than that if you get on Amazon, but like if you're willing to do like the month shipping from AliExpress, then like $2. So like that is insanely cheap.
It is
for what it does.
Yeah, for real. So the only other competitor I know to this is a full-blown Linux system with a wireless network adapter. This is a tiny microcontroller that you can like contribute to. You can already work on it cross-platform. So already you can use it on platforms that you couldn't use, like Airgedon on. So in my opinion, this is kind of the evolution of this attack. It's becoming cheaper, it's becoming easier. And this represents kind of the alpha version of this proof of concept, where we're just kind of showing off how we can present this phishing page and get the password. But in the very near future, I see this as becoming much more robust and having the ability to effectively target, kick off, and then kind of like at the same time both kick somebody off and present this fake page in order to get their network password without actually having to do any like password cracking or anything at all.
Yeah, and if you have ideas for features, like let us know in the comments below, because I can already think of some things I would do with this that would be really interesting. So
yeah. So again, thank you to Varonis for making this show possible. If you guys want to support us, please make sure to subscribe at youtube.com/securityforward. That's SecurityFWD. You'll be able to see all of our previously recorded episodes. And if you also want to take advantage of some of the other great free content Varonis offers, check out the PowerShell AD workshop, which is a really good way to get started scripting AD with PowerShell. You can also check out our attack labs, which shows you what happens when hackers like us manage to break into a system, even kind of when everything else has failed.
Yeah.
So yeah, it's a lot of fun, and hopefully you guys enjoy those resources. If you have ideas for upcoming shows, then you can always hit me up on Twitter. My Twitter handle is Kody Kinsey. Michael's is
the_Hoyd.
And yeah, we definitely welcome your guys' feedback. We hope to see you guys next, next time. We do these twice per week. So we hope to see you either on Tuesday or Friday for our next live stream. We'll see you then. Bye.